Place recognition is an important part of navigation for both robots and animals. In robotics, there's been a surge of interest in addressing two key problems of condition and viewpoint invariant place recognition. Typically, approaches that have solved one challenge have only weakly addressed the other. For example, sequence-based methods have typically been appearance invariant but very viewpoint dependent, while methods relying on traditional or learnt feature descriptors have been viewpoint invariant but only moderately appearance invariant. We draw inspiration from the desert ant, an animal that visually navigates across bumpy terrain at high speed and is believed to use the skyline. To extract the skyline reliably, we use a novel sensing modality, UV cameras. The segmented sky is then represented using spherical harmonics, a frequency space basis for representing functions on the surface of a sphere. We can capture an arbitrary amount of detail by increasing the number of bands. The amplitude spectrum is invariant to rotation about all three axes. As only the upper hemisphere is captured, when tilt occurs, the non-overlapping area has to be inferred. In our sky-segmented images, this area can often be filled in black, and only the phase of the function is affected. Because of this, we are able to match two images despite tilt and rotation by comparing the amplitude spectrum rather than the actual image. Using this as input to a sequence-based localization algorithm, we systematically varied the tilt and found this approach to be far more robust to tilt than using whole images. In addition, we tested our method on a rapid, aggressively maneuvering small robot, where tilt correction to whole images using an accelerometer could not be easily applied. Two fisheye cameras were mounted on our platform, one UV and one visible spectrum. We tested localization on a woodland BMX track and a road in the woods. The tracks included rapid aggressive maneuvers, jumps, and zigzagging. Here you can see the remote control car on the BMX track. In the top left corner is the visible spectrum panoramic camera, and in the top right the UV one. Due to the high contrast on the UV image, the sky and ground are easily separable. Each binary image is then converted to spherical harmonics and used as input to a sequence-based localization algorithm. Performance was compared with FabMap and SequenceSlam. Results demonstrate superior performance compared to both of these conventional systems.